Hello and welcome. This is going to be our homework help video for the homework titled Exploring Periodic Functions. I wanted to start with the right triangle trig review on the back. We'll just do a bunch of these until I feel like we've covered every topic possible. So in each of these, we need to find the missing side or missing angle, show your setup and solution. So for most of these, we're going to be using just SOHCAHTOA. I might even just write that up at the top to remind myself that sine is always equal to opposite over hypotenuse, cosine is always equal to adjacent over hypotenuse, and tangent is always opposite over adjacent. And I have to look at which specific side lengths I'm given so I can know which of these to pick. So I'm given an angle and two sides. That's a really good indication that I'm going to be using trig functions. This is a right triangle. That's important as well. From this angle, I can label all of my sides. The side opposite of the right angle is always the hypotenuse. The side opposite of the given angle is called opposite. And the side that's adjacent but not the hypotenuse is called the adjacent. And it's all based off of which angle you're saying is like the angle that you are focusing on. If I wanted to focus on this angle over here, I could figure out what its measure it is. It would be 30 degrees because of the triangle sum postulate. But I'm focusing on the 60-degree angle. So from here, I've got the opposite is my unknown, the adjacent is my known, so I can set up the equation that connects adjacent and opposite. And that is tangent. Tangent connects adjacent and opposite. Specifically, tangent of an angle is always equal to the ratio of the opposite divided by the adjacent. So the tangent of 60 degrees here equals the opposite x divided by the adjacent 9. Multiply both sides by 9, and I'm going to get my answer. Let's see, take a look at what that is. First, double check your calculator is in degree mode. And then I said 6 times, did I say 6 times? 9 times the tangent of 60 is that missing side length 15.59. 15.59, and then we look at our units. Over here it's meters, so 15.59 meters. All right, and number 2, we're given 2 side lengths and a missing angle. So I look from this angle here and I label my side lengths. Even if they've got a number, I still want to know what they are. So this side has to be the hypotenuse, this side here has to be the adjacent, this side over here has to be the opposite. I have adjacent and hypotenuse. Which of these am I going to use? That's right, cosine. So the cosine of theta is equal to the adjacent, 15.1, divided by the hypotenuse, 16.5. Now how do I get theta by itself? Well, I just simply do inverse cosine of both sides. So the inverse cosine of 15.1 divided by 16.5. The inverse cosine of 15.1 divided by 16.5. I think that's what I had there. And that's, so inverse cosines will take in ratios and give us angles. Since my calculator is in degree mode, it gave us an angle in degrees. That's 23.8 degrees. Right there. All right, that's pretty similar. That's pretty similar to what we've been doing. We'll just pick maybe one more. Let's see, I used one that used tangent, so I won't do that one. That one's tangent as well. This one is cosine. Let's look for one that's going to use sine, since we've already used cosine and tangent. This one here will use sine. So from the given angle, 18 degrees, this side is the adjacent, this side here is the hypotenuse, this side here is the opposite. I'm given the opposite and I want the hypotenuse, so I know sine will connect those. Specifically, the sine of 18 degrees equals the opposite 12 divided by the hypotenuse x. There's kind of a nifty rearrangement you can do here. what I'm going to do is I'm going to multiply x to both sides, and then I'm going to divide both sides by sine of 18. And effectively, these two things are going to swap places. Now I'm left with the equation. Let me give myself some room here. I'm left with the equation x equals 12 over sine of 18. This can just be plugged into our calculator. 12 divided by sine of 18. That's 38.83 for x. So this is 38.83 meters. And that's all that's asking us to do. Let's go do one at the very bottom of the page. The ladder leans against a wall as shown in the diagram. We can see it's a 4-meter long ladder leaning up against a wall at an angle with the ground of 68 degrees. How far is the top of the ladder from the ground? So that must be this distance here. Well, do we have a triangle here? Yes. Is it a right triangle? Yep, because most walls are built at 90-degree angles to the ground. From there, we can label our sides. Opposite the right angle is always the hypotenuse. From my looking angle, this side over here would be opposite. This side down here would be the adjacent. I have the information for the hypotenuse. I don't have the opposite, so I know that I'm going to link this with sine. Specifically, the sine of 68 equals our unknown opposite x divided by 4. Multiply 4 to both sides. 4 times the sine of 68 equals 3. Yeah, that makes sense. 3.7. And let's give it the unit of meters. How far is the bottom of the ladder from the wall? Okay, so now I could use trig again, or I know this is 3.7, so why don't I just use the Pythagorean theorem? A squared plus b squared equals c squared. 3.7 squared plus our unknown b squared equals 4 squared. Let me, my calculator, now do 4 squared minus 3.7 squared. Actually, since I've got that still in my calculator, I'll square it right now. And then I'll do 16 minus that number. And I know I'm going to be taking the square root of that, so let's just do it now. Square root. And I get 1.5 meters. So 1.5 meters. And does that look about right? Yeah, looks about right. 1.5 meters. All right, on to the other side, which has all of our nice sine waves and other kind of wacky looking periodic functions. Worked really hard on finding all of those. Hopefully you appreciate the variety here. State the amplitude and period and midline of each of the 10 graphs below. Just start with this one right here. So one thing it doesn't ask for, but that can be useful, is the max. Our maximum is equal to 1. Our minimum is equal to -1. And then the midline should be right in between those, so right in between 1 and -1. We're going to get a midline on this one, and it's a line, so it should be an equation for a line of just y equals 0. The amplitude is then the distance from that midline. Let me draw it in as a dotted line. All right, across there, a little thinner. The amplitude is the distance from that midline to get up to the max or the min. So that distance there, or that distance there, or that distance there, any of them work. They should all be the same. Our amplitude equals 1 here. And then the last thing, the period. I say you should always count your period from peak to peak. That's just the most reliable way to do it. We could, none of them really hit exact values, so I'll just estimate from here to here. That looks to be about, let's see, each of these blocks is 45. So about 2 blocks. So that looks like it's a period of about 90 degrees equals the period. Let's see. Those are all pretty similar. Let's take a look at this one over here. So its max is right up there at 5. Its min is right down here at 1. Halfway in between 1 and 5. Well, if I have trouble figuring that out, I could actually just average the two numbers. So 5 plus 1 divided by 2 equals 3. That must be our midline. So y equals 3 for the midline. Add that line in. Y equals 3. Now how far do I have to go to get up to my max or down to my min? The amplitude is 2. Now for the period, just go peak to peak. That will trace a whole cycle before it repeats. This right here starts at 6, 7. Well, okay. So it starts at 6. I go 1, 2, 3, 4, 5, 6, 7, 8 units over. So the period equals 8. All right. Let's look at some of these word problems. I'll just do one of them. I think number 4.52 looks maybe a little more interesting. Patient receives regular doses of medication to maintain a certain level of drug in the body. After each dose, the patient's body eliminates a certain percentage of the medication before the next dose is administered. The graph shows the amount of drug in milliliters in the patient's body as a function of time and hours. How much of the medication is administered in each dose? So if right here, this is clearly the point where it's administered, we went from 30 up to 50. How much did we add? We must have added 20 milliliters. How often is the medication administered? So we can see that these vertical lines represent where it's administered. They're 4 hours apart, so every 4 hours. And then what percentage of the drug is eliminated in the body between doses? We go from 50 down to 30. That represents a loss of 20/50ths, or since it asks for a percentage, 40%. All right, last one. Use the blank space, I should say below, to draw a periodic graph with an amplitude of 3, a period of 4, and a midline of 2. So I'm going to make me a graph. Let me use my straight line tool for this. Best kind of graph would be a very long, skinny one like this, so I can show lots of different cycles. It's got an amplitude of 3 and a midline of 2. So from the midline of 2, I could actually maybe even add in my midline of 2 right now as a dotted line. I need this graph to go as high as 3 above and 3 below. So if that's right at 2, we're going to go as high as 5 and as low as -1. Then it's got to repeat every 4 since the period is 4. So if this is 0 right here, it will repeat after 4, 8, 12, and 16 hours, and so on. Now, as I come up with my function, all that matters, it can have some loops, but it's got to go as high as the 5 and as low as the -1. And then if you want to add in like some angles, that would be fine. And then it just resets and traces the same set of y values each time. It repeats a cycle. All right. Now let me draw a few more of these. Oh, I'm losing it. Okay, good enough. So it's periodic, amplitude of 3, period of 4, midline of 2. Hopefully that's been helpful for this homework. help video, and I hope you have a good rest of your day.